Hi dears, welcome to my channel. Today we are discussing the in-text questions of the lesson Magnetic Effect of Electric Current of class 10. These questions may not come directly for the board exam, but these questions are very essential to improve our knowledge. Altogether, 13 questions are there in the lesson and we are answering all these questions. Okay, shall we start? The first question can be seen in page number 196. The question is, why does a compass needle get deflected when it is brought near the bar magnet? What is the answer? The bar magnet is having the magnetic properties. The magnet will be having the magnetic field around it, and when the compass needle, which is made of magnet, when it is brought near the bar magnet, deflection will be caused. It is due to the presence of magnetic field which is created by the bar magnet. Okay, the next question can be seen in page number 200. The question is, draw the magnetic field lines around the bar magnet. It's very easy to draw it, isn't it? So we have to draw the bar magnet initially. And we have to represent the poles, North Pole and South Pole. And we have to draw the lines of forces for the bar magnet. While we are drawing, we have to make sure that we are also representing the arrows through which the lines of force is moving. In every bar magnet, outside the magnetic lines will be moving from north to south, north to south, north to south. Like that here also, north to south. Moreover, there are much more lines also will be there. Bigger lines. North to south will be the motion. Okay. This is how we have to draw the magnetic lines of force for a bar magnet. In the same page, we can see the next question, that is, list the properties of the magnetic lines of force. Can you list the properties? By seeing this, we can say the magnetic lines of forces are having many properties. What are they? These lines moves from north to south direction is the first point. Second one is, they are curved lines and they are closed lines, because here it will be moving also from south to north, and from in outside it will be moving from north to south, and inside it will be moving from south to north. So we can say the magnetic lines of forces are closed. Okay, then the next point is, these lines do not intersect each other. Okay, these lines are not intersecting each other. And then we can say the magnetic lines of force shows the magnetic field. If the magnetic lines of forces are much more crowded at a particular point, we can say the magnetic field strength also is maximum over there. That is, magnetic lines of force are stronger at the poles and weaker at the middle or center. Okay. Then we can also say, when we are moving away from the magnet, the magnetic lines of force are very less effective, and if we are coming closer to the bar magnet or any magnet, the magnetic lines of force is much more strengthened, which shows that magnetic field will be less if we are moving away from the magnet, and if we are moving towards the magnet, magnetic field strength also will be increased. These are the points which we can say. The next question in the same page is, why do not the two magnetic lines of force intersect each other? Why the magnetic lines of force are not intersecting each other? If the magnetic lines of forces are intersecting each other, at that point, at that center point, we can say that there are two directions of the magnetic field. As the magnetic lines of force represent the magnetic field, and as we know the magnetic field is unidirectional, if the magnetic lines of forces are intersecting at that particular point, there will be two directions for the magnetic field. Is it possible? No. That's why they are not intersecting each other. Okay. In page number 201, a question is there. That is, consider a circular loop of wire lying in the plane of table. The current passes through the loop clockwise direction. Apply the right hand thumb rule and find the direction of the magnetic field inside and outside the loop. Considering a circular loop, consider this as a circular loop, and if the loop is lying in the plane, and if the current is moving in clockwise direction, we have seen that according to right hand thumb rule, if the current is moving upwards, the magnetic field will be moving in anti-clockwise direction. Here the current is moving in clockwise direction. So how will be the magnetic field? Here the current is moving in this direction. So the magnetic field will be moving in this direction. Moving in this direction means, according to right hand thumb rule, the magnetic field is moving vertically downwards inside the loop and vertically upwards outside the loop. inside the loop vertically downwards and outside the loop vertically upwards. In this manner, the magnetic field will be generating and it will be circulating. This is what ma? This is according to right hand thumb rule. Okay. In page number 201, a question is there. That is, the magnetic field in a given region is uniform. Draw a diagram to represent it. Magnetic field is uniform in a given region, they are saying. So how can we represent it? We can represent the magnetic field by representing the magnetic lines of force. Okay. By this way only we are able to represent the magnetic lines. See, this is the region and what they are saying is magnetic field is uniform. So we can draw the magnetic lines in a uniform manner. And these lines will be parallel to each other. How they will be? Parallel to each other and they will be equidistant from one another. Okay. And from where the magnetic lines will be moving toward, it will be moving from North Pole to South Pole. So in this region, this will be north and this will be south. And these magnetic lines of force are parallel and they are equidistant from one another in that particular region. It shows that magnetic field is uniform in this region. Okay. This is how we have to represent it. Okay. In page number 202, there is a question. Choose the correct option. The magnetic field inside the long straight solenoid carrying current is option A 0, option B decreases as we move towards the end, option C increases as we move towards the end, and the D option is same at all points. We know solenoid is a current carrying conductor which is in the coiled form and it will be having uniform magnetic field, you have learned. So what they are asking, is it getting 0 or at end it is increasing or decreasing? No, nothing is happening. At every point the magnetic field is same. So which option is the D option is correct. That is, it is same at all points. Okay. Page 203, a question is there. That is, which of the following property of the proton can be changed while we are moving freely in the magnetic field? In the magnetic field, if the proton is moving freely, means what? The proton is moving, proton is a positively charged particle. And if it is moving freely, means what? The electric current is moving. The direction of the electric current is same as that of the direction of the proton. So if the proton is moving, it means the electric current is also moving in the magnetic field. So what happens? When it is moving in the magnetic field, magnetic force will be acting on it. Okay. So what happens? Displacement of the proton will happen. Displacement means what? There will be change in the velocity. Okay. The mass will not be changed even if we are applying magnetic force on it. But the velocity will be changed. So as the velocity is changing, the momentum also will be changed. That is, momentum is the product of mass and velocity. So if the velocity is changing, the momentum also will be changing. So they are giving options as mass is changing or speed is changing or velocity is changing or momentum is changing. The option is C and D. That is, velocity is changing as well as momentum is changing. Then in page 204, an activity is there, and in the activity, they are asking, what do you think the displacement of the rod AB will be affected if the current of rod AB increased, stronger horseshoe magnet is used? Third one, the length of the rod AB increases. Here, in this experiment, there is an electric conductor and the current is flowing through it and magnetic field is generating. And external magnetic force also is applied, that is horseshoe magnet is also applied over there. So it will be having the current, then magnetic field as well as force on the conductor. What they are asking is, what will be the changes which is caused if the first one, if the current of the rod AB is increased? What happens if the current is increased? If the current is increased, it is directly proportional to the force which is applied on the conductor. Okay, the current if increased, the force also get increased on the conductor. So what happens? Displacement of AB happens. Because more force is applied, so it will be displaced a little more. So displacement happens and displacement will be increased if the current is increased. Second one is, what happens if the stronger horseshoe magnet? What happens if the strength of the magnetic field increases? If it is increased, the force on the conductor also get increased. If the force increases, the displacement also increases. So as the force is increasing, with increasing the magnetic strength, what happens? The displacement also gets increased. It is the answer. The next question is, what happens if the length of rod AB increased? What happens if the length of the rod AB increased? That force acting on the conductor also gets increased because much more length is there. So more force will be acting. So what happens? Displacement also happens. So the displacement of the rod AB again increases if we are increasing the length of the rod AB. This is the answer. The next question in page number 204 is, A positively charged particle, that is alpha particle, is projected towards west, is deflected towards north by the magnetic field. What is the direction of the magnetic field? Here they are saying about the positively charged particle, that is alpha particle. The motion of positively charged particle is equivalent to the direction of current. So, in which direction the alpha particle is moving, in that direction the current will be. Okay. So, in which direction the electric current is moving, it is projected towards west. West side the current will be moving, and then it is deflected towards north by the magnetic field. Means what? Magnetic field is not towards north. They are saying it is deflected by the magnetic field. Means what? The force is acting on that alpha particle is towards north. Means what? Force is towards north. Okay. What they are asking? They are asking the direction of the magnetic field. So, by how can we understand which is north, which is west, which is east, and like that? It can be easily understood. Consider this point as east. This is east. Okay. So, this will be west, right? This is east. This will be west. Then how can we identify the north? If you are facing towards east, where is your left hand? The left hand is in this direction. So, this will be north. Okay. This will be north, and the right hand shows the south. So, left hand shows the north and right hand shows the south if we are facing towards east. So, we can understand that west is this side and the north is this side. Okay. So, Fleming's left hand rule we are applying. Force, then magnetic field and current. The current's direction is towards west, and the direction of the force is this direction. Okay. The west current. Here north, what the force, then where will be the magnetic field? It is moving towards upper side or upside is will be. So they are giving option towards south or downward or towards east or upward. Which is the direction now? The direction is towards up, because we are applying Fleming's left hand rule. This is the direction of force towards north, and this is the direction of current towards west. Then it will be the direction of the magnetic field, that is towards upside. Okay. Page number 205, you can see a question, that is, name 2 safety measures commonly used in electrical circuit and appliances. What are the safety measures which are used in these appliances? The safety measures are electric fuse and earth wire. The next question is, an electric oven of 2 kilowatt power rating is operated in the domestic electric circuit, that is 220 volt, has a current rating of 5 ampere. What result you are expecting? Explain. Electric oven is connected to 5 ampere current. Is it correct or not is the question. So what is the current which oven is drawing? We have to understand. Then only we can say anything. So we know already that current I is equal to power divided by volt. Isn't it? Power they have given as 2 kilowatt. Means what? 2000 watt. What is voltage? 220 volt. Okay. Here we can cut off 0. So we can write 200 divided by 22. We know 22 into 9. 22 into 10 is 220. Here it is 200. So 10 is not correct. So 9, let me see. 2 into 9, 18. 198 is the answer. So 9. 198. What is rest? 2 is the remaining. If we are putting 0, will it work? No. We have to put again 1 0. So, decimal point 1 0 is added here, and then 200. Again 9 will come, isn't it? 198, and the remaining again become 2. Like that it will be moving. Means what? This is 9.09 is the current which is required for the oven. Current required I is equal to 9.09 ampere is the current which the oven is required. But it is connected to what now? 5 ampere current. So what happens? It may result in overloading, or the heating will be happen to the electric circuits. All these may result. From this we can understand how dangerous it is if the appliances are not properly connected, isn't it? The last question is, what precautions should be taken to avoid the overloading of the domestic electric circuit? What are the precautions? From the last problem itself, we understood one thing, that is circuits should be properly current rated and the appliances should be connected accordingly, isn't it? Otherwise what happens, overloading may be resulted. And secondly, we can say the insulations should be proper for the circuits, and we have to check the wires in between or from time to time whether the insulations are correct or not. Okay, and we can say that the electric circuits has to be divided into various sections, and in each section fuse wire should be connected. The fuse wire will help to safeguard the appliance from getting damaged. Connections of too many appliances should not be given in single socket. In single socket, if too many connections are given, what happens? Overloading may be resulted. All these questions can be done for avoiding the overloading. Okay. These questions we have answered, and these questions may come directly for the board exams, or these questions will be helpful for you for understanding the concept very well. Okay. We can see the next time with a new lesson. Bye.